Okay, you guys, we're back in, we're sheltering in and staying safe and saving America. So here we go. Homework 41 was the last one, simplifying radicals. There's the assignment up there. Hopefully you got that done. I sent you out the answer key, so you should definitely check your answers along with the answer key to make sure you're understanding how everything goes and that you're getting the problems all done correct. I'm going to do a couple of these problems from homework 41 and then jump right into today's stuff, which is adding and subtracting radicals. It's going to be a very, very short video, probably 10 minutes or so total. So we'll just jump into it and we'll be done with it shortly. And you won't have to watch a very long video. Or if you want to watch a very long video, you can watch it over a couple times. All right, here we go. Let's start with the first problem I'm going to do from your homework. It's called homework problem number 33, and it says square root of 4,000. Okay, I'm going to do this problem two different ways. You only have to do it one way, but I'm going to do it two different ways. I'm looking at this and I'm saying, well, gee, what if I don't know what the biggest perfect square number is in 4,000? Well, you don't have to necessarily start with the biggest perfect square number. You can start with any perfect square number that you can find. For instance, I don't know the biggest perfect square number, but I do know that 100 goes into 4,000. So I'm going to choose 100 to be my perfect square number, right? So I'm going to make it root pretty. Pretty is going to be 100. Ugly is going to be 40 because it's 100 times 40. Now, so far so good, okay? But 40. Is there a pretty number sitting inside of 40? Is there a pretty number sitting inside of 40? Well, 40 has a 4, right? It's 4 times 10. So wait a minute, I already have this as one of my pretty numbers. Now, I can break 40 into root pretty times root ugly, which gives me root 4 times root 10. Now notice, oh my gosh, square root of 100 is 10, oops, 10. Right? Square root of 4 is 2, right? So it's 10 times 2 times root 10, which gives me 20 root 10. So that's what the answer simplifies to, 20 root 10. And guess what? That's the answer. Now, what if I looked at this root 4,000, and what if I realized, you know what? There's actually, see, because if 20 comes out here, there must be sitting a 20 squared must be sitting inside of there. What's 20 squared? 400. So I say, oh, this must have a 400, which actually does turn out to be the biggest perfect square, right? 100 is a perfect square that's sitting inside there, but it's not the biggest. The biggest perfect square number is 400, okay? So, and it's 400 times 10. So notice, square root of 400 is 20, so I could go straight to 20 root 10. So if you happen to see the biggest one, it saves you a step or two. So there you go. All right, now let's do the next problem and get that. Actually, let me move on, and then I can erase. Okay, negative root 80. Negative root 80. By the way, that's problem number 46 from your homework. Negative root 80. 46 is negative root 80. Well, I happen to know, and hopefully you know, that 16 times 5 is 80. So don't forget, leave the negative just sitting there. Root pretty, root ugly. What's pretty about 80? 16. What's ugly? 5, because 16 times 5 is 80, right? Square root of 16 is 4, so it's going to be negative 4 root 5. Cha-ching. There you go. Okay, let's do one more. 47. Okay, here's 47 from the homework. It says 5x root 63. 5x root 63. Okay, 5x is already on the outside, yay. Root 63, let's do root pretty, root ugly, okay? What's pretty about 63? How about 9? What's ugly? 7. 9 is the biggest perfect square number. Now, Square root 9 we know as 3, right? So look, it's 5 times x times 3 times root 7. Well, the 5 times 3 gives me 15 times x times root 7. So it's 15x root 7. And that's the answer. Okay, those are the problems from last night's homework that I was going to work out for you. Now we could move on to today's material called adding and subtracting radicals. That's what we're going to do, adding and subtracting. Now, here's how it works. Okay, the first two problems are super duper easy. What is 3 root 7 plus 8 root 7? Well, if you're not sure what to do, if I ask you to guess, in fact, I am asking you to guess right now, guess what you think 3 root 7 plus 8 root 7 would be. If you had to take a stab at it, what do you think it would simplify to? Most people are going to say 11 root 7. And the reason most people are going to say 11 root 7 is because that is the correct answer, and that's how you do it, okay? It is that easy. Don't make it harder than that, okay? Now, if you're not sure what to do, see how they both have a common root 7 there? Ask yourself, what if that was an x instead of a root 7? If that was a 3x plus 8x, most people realize that would be 11x, right? It's the same idea. In fact, you can even think of it as a reverse of the distributive property. You could say, hey, 3 root 7 plus 8 root 7, they both have a root 7 in common, so I can factor out the root 7. Oops, put root 3. I can factor out the root 7, and I would just get 3 plus 8, which is 11 root 7. Now, that to me is more confusing than just realizing 3 root 7 plus 8 root 7 is 11 root 7. That's fine. You don't have to go through this is actually what's happening behind the scenes, whether you realize it or not, okay? But most people realize that, so that's not usually a problem, okay? But how about 3 root 7 plus 8 root 5? How can that combine together? Well, the answer is it can't. Just like 3x plus 8y, right? X and y, they're different, they don't squeeze together. They have to have a common, they have to be similar terms, which means it has to have exactly the same thing underneath the root in order to combine them together. If they don't have the same thing under the roots, they can't combine together. So that guy does not simplify, it just stays 3 root 7 plus 8 root 5, and that would be the answer. It cannot combine any more than that. Okay, that's the basics. Now, let's go ahead and do the next step. We're going to step it up a notch. Not too bad. Don't get afraid. It's not too bad. Okay, how about root 12 plus root 27? Here we go. Now, if we do what I just told you, you might say, hey, root 12, root 12, hey, are these the same or different? Well, they're different, right? So can we combine things together that are different underneath the radical? No, we can't if we're adding or subtracting them. No, we can't, so I guess we're done. Move on to the next problem. Well, it's not that simple. The thing is, you can't decide whether they can be combined or not until you simplify each of the radicals, right? Just because these are different doesn't mean they cannot be simplified. They can, or combined. They cannot be combined. Because if you simplify them, you might find out that they are similar terms. Let's see. Root 12. Let's forget this guy right now. Let's just look at square root 12. Okay? That's going to be square root pretty. That's square root ugly. What's pretty about 12? 4. What's ugly? 3. Square root 4 is 2. So this is 2 root 3. Easy enough. Okay? Plus root pretty times root ugly. What's pretty about 27? 9, right? What's ugly? 3, right? And then, wait, root 9 is 3, so it goes plus 3, root 3. Then, oh my gosh! Oh my gosh! I can't believe it! They look like they were different, but guess what? When I simplify, you know what I find? Es lo mismo. Es lo mismo. They're the same. Oh my gosh, I can combine them together. Oh my gosh, 2 root 3 plus 3 root 3 is 5 root 3. Oh my gosh, este es la respuesta. You know it. You know it! Yeah, all right. All right, enough of that. On to the next problem. How about this guy? Holy moly. 3 root 8 plus root 45. Now, you might say, wait a minute, they're different. And I say, slow down, slow down. Let's see if we can simplify it at all. So here we go, here we go. Make sure your finger's not on the lens.
It's not.
Okay, all right. All right, so we've got 3 root pretty, root ugly. What's pretty about 8? 4. What's ugly? 2. Square root 4 simplifies to 2. So look what we got here. 3 times 2 times root 2. That's going to be 6 root 2. Okay? Plus root 45. Root pretty, root ugly. You know what's pretty about 45? 9. You know what's ugly? 5. Square root 9 is 3. So we get 3 root 5. And then you say, wait a minute. No es lo mismo, es diferente, right? And when they're diferente, that means no combining. So there's the answer. That's as simple as it gets. But it does simplify from here. At least you go down to here. Okay. It's okay. Here's another one. Okay. 5 root 28x. 5 root. I don't like this. Let me get a better one. Here we go. Okay. 5. There we go. Root 28x minus 8 root 7x. Okay. Well, let's see. 5 root pretty, root ugly. What's pretty about 28? 4. What's ugly? 7. What's pretty about x? Not a darn thing. Flat out ugly. Okay, square root of 4 is 2. So 5 times 2 is 10 root 7x. Okay. Minus 8 root 7x. Wait a minute. Root 7x is just flat out ugly. Ain't nothing pretty about it. So you go 8 root 7x. Oh my gosh. Oh my gosh. Es lo mismo. So 10 this guy minus 8 this guy makes 2 of these guys. Cha-ching. There you go. Okay. Hang in there. This is the final problem. The final problem for today. Ready? Here it is. Root 125b. Root 125b plus 3 root 20b minus root 45b. Okay. We're going to do some pretty and some ugly right here. Root pretty, root ugly. What's pretty about 125? How about 25? What's ugly? 5, right? 25 times 5. What's pretty about b? Nothing. So this thing's going to simplify to root 25 is 5 root 5b. That's what this guy simplifies to, okay? Plus 3 times root pretty, root ugly. What's pretty about 20? How about 4? What's ugly? 5. What's pretty about b? Nothing. It goes on the ugly side. Square root 4 is 2. So 3 times 2 is 6 root 5b. 6 root 5b. B. And then finally, let's see, minus root pretty, root ugly. What's pretty about 45? 9. What's ugly? 5. What's pretty about B? Nothing. It's on the ugly side. This is 3 minus 3 root. Oh my gosh! Oh my gosh! I can't believe it! The fortune is with me! Look, all 3 of them have the same thing underneath the roots. That means I can combine all 3 of these. 5 plus 6 is 11, minus 3 is 8. 8 root 5b, and este es la respuesta. So there you go, people. That is the grand finale. I know, not that exciting, but hey, what can I say? That's it. So, here's the homework. Shouldn't be too bad. Homework number, it's not number 70. What is wrong with me? It's homework number 42. How do I have it written as 70? What's wrong with me? I don't know. Let me change that. It's 42. Sorry, people. 42. There we go. Much better. Much better. Okay. So, homework number 42, page 713, 15 through 29 all. Have fun, and I'll see you next time.